Today class we will discuss about pumping lemma for CFL language and some closure properties of CFL language, also some decision problem of CFL. So, already we know pumping lemma, before also we know that this pumping lemma prove the language is not regular. If your language is regular, the not regular, using pumping lemma we can prove it language is not regular, means pumping lemma, if pumping lemma satisfy your language if regular, if it is not regular, then it will prove that this pumping lemma properties not satisfy the language. So, like that context free language we can prove it using pumping lemma, either your language is context free language or not. So, how to prove this pumping lemma? Like it is similar process like regular language, how to prove the regular language. So, it is saying that you see here this L is the context free language and there is a pumping length P such that string S any string S belongs to L. So, length S should be greater than or equal to P can be written as. So, here we divided into 5 part. If you remember in regular language whatever string we have we divided into 3 part, that is U V W, you can say here is the U V W X Y. Then here is the V W X is, if it is a context free language, then it must be satisfy these 3 properties. If it is not context free language, then this any one will be violate from these 3 properties. So, we will check that. See here it is saying that we have to take a pumping length. So, all string must be any string from S greater than equal to pumping length can be written as S U V W X Y. We have to divided 5 part to string. So, V W X is less than equal to P. So, V W X whatever V W X all 3, if you combine all 3, that should be less than equal to the pumping length, and there should be V x should be greater than equal to 1. You cannot take as empty V x, you have to take the something greater than equal to 1, and for all I greater than equal to 0, you can say here this is the u to the power this is u to the power v, you can see here this is u to the power v u to the power v u v to the power I w x to the power I and this is y belongs to n. So, all I whatever I will take, I may be 0, may be 1, for all I this should be satisfy whatever string will be generated, that should be belongs to L. So, this is the properties of the how to prove context free language is not context free. So, we already know we know that if a context free language is there, we can have to design a push down automata for this, either it is a deterministic push down automata or non deterministic push down automata. So, we cannot have always check that you have to, a language is given to you, one language is given to you, you will check it by the, you started to draw the push down automata. If you could not draw, then you can prove it that it is a not context free language. We cannot like do that. So, that is why we follow the pumping lemma properties. Using pumping lemma we can check it, either this can be designed by the push down automata or we will go to the higher machine like the Turing machines. So, here context free language is there, then this should be satisfy these 3 properties. If it is not there, then it will be go to the higher machine like the Turing machine, that can be accepted, that we cannot design in PDA. So, first step is saying that whatever language is given, we assume it is a context free language, then take the pumping length, then after that apply these 3 properties. If it is okay, satisfy, For all I, last very important is third properties. If all I greater than equal to 0, then you can say this is accepted. This can be a context free language, otherwise it is not a context free language. So, let us take an example, we will check it. Take an example here. So, I have taken here example a to the power n, b to the power n, c to the power n, n greater than 0. So, we can have 3 comparison at a time, 2 comparison you can say a to b. If you will see simultaneously you can say this one is not a context free language. Why? Here is the a is comparison, a comparison with b and a comparison with c. A comparison with B and A comparison at a time 2 comparison. So, we do not have the push down automata for this, because push down automata we have to use a stack. So, what you have to do? You have to push all A, for each B you have to pop A, then you can compare with A B and make it stack empty. Oh, and then what about C? We cannot compare with C with A, that is why it is cannot be designed by the push down automata. We know that in push down automata we use the stack data structure. So, what you have to do? For all A push into the stack, for each B pop A from the stack. So, on that case we can equalize A to B, but we cannot equalize to A to C. That is why this is not possible to design in a push down automata. So, another thing, here you can use 2 stack PDA, 2 stack, using 2 stack we can have PDA, but 2 stack is PDA is equivalent to Turing machine, this is not considered as a push down automata. So, that is why this is a contest using pumping llama, this is a not a contest free language. So, how we prove using pumping llama that this CFL L is not a CFL. So, now check it. So, we have suppose take a pumping length, suppose we will take here a string, take a string here L, we will take a string S, S is suppose we have A, B, B and C, C. So, we can have a string, this is A, B, B, C, C. So, when we will take n as a 4, n as a 4, this language derive a string, we consider this string. So, now we have to see the properties, what you have to written? It is written that we have to take a pumping length, suppose take pumping length, the string is a P is 4, pumping length is 4, pumping length is 4. Then after we have to divide the string, U V W, UVWX, UVWX. So, here we have to divide the string. So, now, so this is U, suppose U take as a and VWX you take as a B as a B and W as a B, W as a B and X as a B. So, you and here you can say this is 4B, okay, you take A as a 4A, 3A. So, now, so this is X is B, C, 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 C. So, you have divided, you can anyways but divide, but you have to take care about the pumping length. And first step is saying that, this VWX should be less than equal to P. So, here it is saying that VAB VWX is less than equal to P. So, you can check it, here we have taken A, B, B and B, this is less than equal to pumping length 4, pumping length 4. So, this is one condition, then second one saying this is Vx should be greater than equal to 1, and you see Vx is greater than equal to 1, yes. So, you can say Vx is greater than equal to 1, greater than equal to 1, yes. You can say check it, V is A V and X is B. which is greater than equal to 1, greater than equal to 1. So, now very important, these two properties it is satisfied. So, we will go to the third properties, this is the very important, how this third properties work, how this third properties work. So, this third property is saying that, third property is saying that, you see here what is the third property is saying that u, what is the u v I w x to the power I and this is y belongs to L for all I, for all I, for all I. So, I may be 1, may be 2, may be 3, may be 4 or may be any time of I. So, now we will check how is it satisfy the properties. So, let us check u is 3a, u is we have taken 3a. So, v is a b to the power I and w is b, v x is v is what is the u v x y. Let us check, we have not taken y here. So, we have to take here v w x, x is we have taken x as a u v w x as a, let us check, we have 1 2 3 4, we have not taken consider as a y. So, y is you can take here let us take y w v is a v, w you can make it epsilon, you can make it epsilon, no problem. So, here w you can make it epsilon, w can make epsilon. So, empty and x is b and y is b c c. So, now you see this is epsilon, you have to take it epsilon, w is epsilon, w is epsilon and x is b to the power I, b b, x is a b, we take here this is double b, okay, this is double b to the power I and this is b c c c, 4 b c. Now, we got this one triple a b to the power I, then epsilon, w is epsilon, then b b to the power I, then b c c. So, take any I, any value of I, suppose I is suppose I will take here I as a 2, I is 2. So, what will be there? I is 2, you see here this will be a and a b and here b b b, I is 2, 2 times it will be repeated b b b and then after b c c c. So, could this string does not belongs to L, this string does not belongs to L, this string does not belongs to L. So, what it is saying that pumping lemma, it is saying that u v to the power I w x to the power I y belongs to L for all I. So, here we can prove that we assume it, we first thing we assume L is regular, L is CFL, assume L is a CFL context free language, then this should be satisfy 3 properties, but we got the contradiction, this string never be generated by the L, we got the contradiction, whatever string 4 times a b 4 times 5 times b c c, these strings never be generated by the language. So, this condition, this third properties violate the rule, third properties, this is the violation of the violation. So, that is why we got the contradiction. This grammar, this context free grammar, this language, whatever we assume this L is a CFL. So, this is not a CFL, because this is does not satisfy all these properties 1, 2, 3. That is why here we got the contradiction. So, here we can see whatever division, just you have to consider it. Division is you can anyways you can take A B like that, B C, whatever you this division U V W X Y, but you have to take care about the V W X, and V x should be greater than equal to 1 and V W x less than equal to B. These two condition you have to take care about when you will divide this. So, like that you can prove all the languages which are not context free. You just assume it and apply these 3 context free, take a pumping length for this find a string, then after check it, if you got the contradiction, then language is not context free. Clear? So, this is now this is what we prove this pumping lemma for context free language. So, we no need to check, you have to check it, either you have to design a push down automata or not. If not design, then we will go to the Turing machine. So, no need to check, if you will prove it in by the pumping lemma. If it is satisfy the pumping lemma properties, then it is a context free, not satisfy contradiction, then it is a not context free, we will go to the higher machines. So, closure properties of context free language, closure properties of context free language. The closure properties of context free language is saying that L is a context free language, then we have like a regular language, we have 2 regular language, union of regular language is regular language, concatenation of regular language is regular language. Here also some properties, if a 2 language is there, L1 is a language is context free language, L2 is another language context free language, union of these 2 also we have a context free language. Means if L1 is a, you can say this, what is the meaning of this? This L1 is a context free language, L1 is a context free, then L1 is a CFL, then we have PDA for this, we have a PDA 1, PDA push down automata, this is for L1, then L2 is a CFL, PDA L2. This means if we have union, also we can have a PDA, L1 union L2 also a CFL. So, we can have also a PDA, we can have PDA. This is the closure properties of a context free, means we have one PDA given L1, another L2. If union of these 2, this is the also a PDA. So, here CFL are closed under concatenation also. Concatenation, if L1 is a context free language, then concatenation with L2 also it is also a context free, means we can have a push down automata for that. Also clean closure, close under clean closure, also clean closure like L asterisk, you have already known that this is the clean closure. So, CFL are not closure the intersection and complementation. If a complement, one CFL language is there, we have designed a push down automata, we cannot say that after complement of CFL we can have also a push down automata, but that is possible in finite automata, already we have seen it. If a finite automata is there, we can complement it to a finite automata also. If we will complement that also we will get a finite automata, but context free language it is not possible. Context free language, because here it is some different kind, we cannot in context free language, and some language are accepted by the deterministic push down automata and some language are accepted by the non deterministic push down automata. That is why Here is the different kind of scenario, that is why we could not do. Here is the not closure under intersection and complementation. If two CFL is there, if it may be intersection, that may not be context free language, but it will means it may not be accepted by the push down automata, will go for the higher machine. So, we could not say what will be there. So, this is the these two are not closed under intersection and complementation. So, here you can say suppose one language L1, L1 is you can say another, I have written the some questions you see here. L1, L1 is A to the power 2n, B to the power n and W. Can you say that identify what are these questions came in GATE exam, like this type of questions. Two languages L1 A to the power 2n, L1 is this one and L2 is WWR. So, here you can say all the strings are here A to the power A, B one string, and here the WWR, whatever string we have, also reverse of this you can say this is a polyandrome, this is a polyandrome, WWR is a polyandrome string. So, we have given this language. So, option is given I, L1 union L2 is CFL, L1 is a CFL, L2 is a CFL. These three cases are given and which of the following options are correct. From these three options here it is written A is only I and 2I, only I and third I, all I and second I and third I, and D is none of this. So, can you identify which one is the correct options? So, first of all you have to check it either L1, L2, what are these languages, L1 is context free or L2 is context free or not, like that you have to verify. So, you see this L1 if you will go through the pumping lemma, apply this language for the pumping lemma, that can be satisfy the properties of the pumping lemma and you get this L1 is a context free language. Otherwise, you can have direct, you can identify there is a one comparison between A and B, there is a single comparison, one comparison, single comparison. When there is a single comparison, that can be accepted by the push down automata, no need to check anything. So, here only A to B there is a one comparison, A to B. So, that is why this is a context free language that can be accepted by the push down automata, deterministic push down automata also. This one WWR, this is a polyandrome string, you will get this type of string, suppose A, B, B, A, this is W and this is WR, WR means this is the reverse, R means reverse, WR means reverse, R means reverse. So, now these two, this is WWR already we have done in push down or some push down automata is there, WWR we have this language is a context free language because we can have a push down automata for this, So, this is a context free language, if you will use the pumping lemma you can prove it also. So, this is also a context free grammar. So, you can see L1 is right, L2 is right, also union, already I told that properties of closure properties of L1, L2, L1 union L2 also a context free language. So, these three options are correct. So, option C is the right one, option C is the right one, other three are wrong, all three are correct. So, this is the this kind of question came in GATE exam. And another question here, question number 2, here it is same thing, just I modified WW, here it is not WW, this is not WWR. So, this is not reverse, same string, suppose here we will take here AB, then this should be AB. So, this is BB, then this should be BB. So, like that it will be string will be generated, but here this one can you identify which options are correct, which of the following options are correct. So, here you can say L1 union L2, L1 first you have to check either L1, you know that already L1 is the CFL, there is a one comparison, but L2 is not CFL, L2 will go to WW, this one is not CFL, L2 is not CFL. So, what you have to do, this one is not CFL. So, this one I option third I option is correct, wrong, third Y it is wrong. So, this one right, L1 is CFL. So, what about the L1 L1 union L2? So, if this is not CFL, L2 is not CFL, then this will be not accepted by the push down automata, it will go to the higher machine, this will be accepted by the Turing machines. So, already we know in Chomsky hierarchy one diagram is there from the starting, you know that this is the regular language, for this we have finite automata, then after we have context free language, we have push down automata, then after we have context sensitive language, we have Turing machine. So, like that you have to go to higher machine, recursive language or recursive enumerable, like that you have language. Now, you check if what is the union of CFL and then higher, it could not be CFL. So, if any CFL language that is also accepted by Turing machine and some language is not CFL means higher than CFL like CFL also it is accepted by the Turing machine. You will see this Venn diagram means this finite automata all either regular language, this regular language can be accepted by the push down automata, finite automata, Turing machine, any other higher machine. Similarly, PDA can be accepted by the Turing machine also, this CFL can be accepted by PDA, can be accepted by the Turing machine. So, union always higher, union always take the higher, or you can say this cannot be CFL, because L2 is not CFL, it is a CSL. So, higher you have to, when it will be union you have to consider higher one. So, CSL, this is a L2 is a CSL. So, you can say L1 is CFL, L1 is CFL and L2 is CSL. So, L1 union L2 is CSL. So, it could not be CFL. So, you can say which option is correct, only I L2 is not, L2 is a CFL, it is false, L1 L2 is a CFL, it is also false, WW cannot be accepted by the push down automata. So, you can say here this one only I and second I also wrong, this is wrong, this is second I and third I also wrong, and you can say none of this is answer. So, here L2 is not CFL, L2 is a CFL, no, L2 is not a CFL. So, L1 union L2 is a CFL, no, L1 L2 is not a CFL, L1 L2 is higher language. If you will take like that in L1 is, suppose we will take L1 is regular and L2 is CFL. So, when you will take here L1 union L2, then this is a CFL. So, union always take whatever union or intersection, it always take higher, but in CFL you have already seen that this is does not satisfy the closure properties of intersection, it is satisfied only. So, this type of question may you will get maybe get in competitive exam or GATE exam or NET exam also, this type of question will may be coming many times. So, this is the simplification of and these are the reference, and thank you so much.